Fun.
Yeah.
What's this called? Optimization?
Optimization. I love this lesson so much.
Quit it.
No,
You
seriously,
said
this is
that.
probably one of my favorite things.
But
we have with
it's
this.
hard.
You say everything you think.
This
That's
is
actually
legit
bad.
my favorite thing.
Hey, but quit.
Ever.
You just said it was probably
Can I
one
just
of my
ask you
favorite
something?
things.
Well, no, this is
I
probably
need
the
a
top.
little rundown of something really, really quick. Okay, so today and tomorrow lesson. Friday,
I was gonna do the quiz, but I'm now
But
doing
not.
the quiz on Monday.
so Monday quiz. Tuesday,
Review, and then Friday. Well, no, you won't have me on Thursday, so then you're a
so
final
we have
on
2 days to do this.
Oh my gosh.
We have you on
We have 2 days to do
Thursday
the
and
review.
Friday.
in class to ask questions on the review.
But how big is the review? Big.
It's like 25 problems.
Oh,
Oh,
okay,
that's
that's
not
not
bad.
bad.
The
Yeah,
last one was like 30.
Yeah.
She literally gave us test.
We have you
quizzes that were
Thursday
like
and
80
Friday.
problems and gave us
Huh?
time to
I have you Thursday and Friday because I have some tea.
Well, we all have your own answers.
Well, I'm not sure how the SRT thing's working. They might just have us do a certain class, like keep a class for
Well, they
SRT.
should
So I'm not sure how that's going yet.
That's stupid. I'll jump off a cliff.
I also thought, aren't we doing even classes on Thursday?
No, we're doing odd classes Thursday, even classes Friday. So 1, 3,
Okay.
5, and 7 are Thursday, 2, 4, 6,
You know, I'm
and
gonna
SRT
fail your
are Friday.
final no matter what.
I curve it. If that makes you feel any better.
I got like a D on the pre-cal one, so.
This class.
I also got a D on that.
Yeah.
Yes.
Yeah.
You know, I can
That's
get
not a
A's.
bad grade for one of my
Well,
finals.
at least you
You
don't
know
feel
what?
like
Oh,
it's a
God.
terrible grade.
Yeah.
Really not.
Listen, I can get A's. Finals are so stupid. I get A's in both quarters. You get D on the final. Get a C.
Just because how she makes it.
I know you're joking.
I'm not judging you, I'm judging your finals.
My finals are hard. I know that. That's fine. Well, I can't make them
You
easier
want
and
us
still
to
test
fail.
over the things I have to test
You
So
over.
want
I
us
just
to
wrote
fail.
an essay for English about how
Okay,
your
so-
teachers don't set you up to fail.
So
Proving you wrong.
I'm going to do something I've never done before to help you out prior to the final exam. I can't tell you what it is, but I can tell you that I'm going to allow you to do something that I've never done before in class
The
Yeah.
whole final's gonna be partner work.
prior to the final exam.
Oh.
So that's all I'm going to tell you. So remember that I'm not a terrible, awful person when you take my final because I'm going to let you do something.
Wait, prior to-
Don't worry about it.
Oh,
I've been recording this whole time, so whoever watches this video, I'm so sorry.
No one's.
I'm not sorry.
It's not gonna be done.
I'm gonna end up watching it later.
Pepe. Wait,
So you can relive this conversation.
Hey, none of them are here. None of them are in the call.
Yeah, no, Ethan's in the call. And actually somebody else is too.
Who else would
It is Jeff!
Who else would it be besides Jeff?
I don't know, I was just-
The only two that were thinking was about
Just check it. Okay, so let's actually do this lesson now because it does take a hot minute. So when I'm talking about optimization, there are some steps that we need to follow. When we're optimizing, we are finding the optimal conditions for a certain scenario or problem. So a lot of times we're looking, a really popular example is we're looking for the dimensions that will give us the maximum amount of area for this shape. Okay, so that is an optimization. We are optimizing the area for certain dimensions. We'll find the dimensions that fit that optimization. So this also works for minimizing. So if I have like a fish tank that I'm building, I want to find the minimum surface area I can have that would give me a certain volume. So we're finding minimums or maximums, how they apply to real world situations. So the steps are identify the optimization equation. So we have to identify what we are optimizing, whether it's area or volume or surface area. Optimization equation. Don't have to decide yet. We haven't even done a problem. Did I say what? Step 2. Write all equations related to your problem and the information that they gave you. Oh no, it's a 7-step process. It does not really 7. It is 7. Okay, so 3 is to substitute. We want to get our equation in terms of one variable. So it's in terms of 2, I can't optimize it. Step 4, we need to find the first derivative.
Will this make more sense when we do
Yes, oh yes, tons more sense. But this is a good thing to fall back on if you're confused or stuck at a certain spot. We can say, okay, I did steps 1 through 4, now I need to look to try and do this. Step 5 is to set the derivative equal to 0. Step 6 is to find the critical values. So the answers I get when I set it equal to 0, very similar to our critical points. I need to check to make sure that one or both of them is going to work.
Wait, it's not critical points.
No, it's critical values because I'm looking at values in a certain scenario, but it's the exact same as critical points. I'm just not looking at a graph. And then step 7, determine which critical values answer the question being asked.
Is it values or points?
Values for this. But critical values here are the equivalent to critical points on a graph. So in your notes, I do have, I believe, 9 examples completely solved out for you. We're going to try and get through 4 of them today. And then we'll do some more tomorrow, and then I'll let you work together on some practice problems.
Aaron asked a question.
I heard, what are we doing? But I also heard you say something. So examples today, some examples tomorrow, and then practice problems together tomorrow.
You're telling me it takes the rest of the class,
That's what I was
4 of
gonna
these
say.
problems.
The fact that we still have the majority of class left, you said you're gonna get through.
This is one of the big ones, yes. When we had block scheduling, I took 2.5 classes to teach this.
What?
Just because they're extensive and you want to work through the first couple really slow. Okay, so let's do our first example. On your final exam, I will only put one of these, and before the final, I will tell you 3 options or scenarios that I will choose from. So you will be able to narrow it down a little bit.
Is that what you're doing for our?
What is the equation?
Yeah, so they're all different types of story problems. So we're gonna go through several different types or scenarios, and I will narrow it down to a couple that you should maybe write examples of or look at before the final exam.
Does it give us the equation in the problem?
No, but they're all basic equations like area or volume or
Oh.
perimeter or stuff like that. And if it's a different one, then it'll give it to you in the problem. Okay, so first example. Given the curve, y equals natural log of x minus x. Find the coordinates of the point on the curve that is closest to the origin.
Did I just see you look at the problem and roll your eyes?
No.
Yes.
I actually roll my eyes without knowing that I roll my eyes. So I apologize if I'm ever talking to you and I roll my eyes, because I honestly don't know that I've done it. My husband says that I do it on purpose whenever I'm talking to him, because apparently I do it a lot. I actually don't, but he thinks I do. Okay. Are we ready?
I do it sometimes when I think.
The first thing I would like to identify is whether I am minimizing something or maximizing something. So in this problem, it is asking me to identify which point on this curve is closest to 0, 0. So if I'm comparing the distance from 0, 0 to this point, am I maximizing that distance or minimizing?
Wait, what? No, neither. What?
If I'm looking for the point on the curve that is closest to 0, 0, that means I'm comparing the distance from 0, 0 to that point. Am I looking for a minimum distance or a maximum distance?
Minimum.
minimum, because I want the closest, which means I want the distance to be as small as possible. So this tells me that I'm using the distance equation, and that's what I'm optimizing here. Do we know the distance equation?
No.
Okay, so I figured you don't. Our distance equation
I've heard it before.
is the square root of x2 minus x1 squared plus y2 minus y1 squared, where x1, y1 is 1 point, x2, y2 is the second point that I'm comparing the distance between.
Oh,
That kind of ringing a bell in here.
Yeah.
no.
Not at all.
Okay, this is something you're going, yeah, we should have
learned
done
this
in
in physics.
geometry
Right.
and in science classes. Oh, yeah.
I was like, I did so good in that class.
Don't we just get rid of all the
Also, the
squares
salary
and
kind of
drop the
slack.
square root?
Kind of. So in order to use this equation, I have to know something that I'm plugging into it. So do I know any of the points that I'll be comparing the distance between?
Y1.
Do I know any point that I'm comparing the distance between or to?
0.
0, 0, because it wants the origin, right? So I'm gonna go ahead and plug in x1, y1 is 0, 0. So when I do, I get distance equals the square root of x2 minus 0 squared plus y2 minus 0 squared. Since I only have one x and one y in there now, I can take away the x2 and the y2 part of it and just rewrite this as the square root of x minus 0 squared plus y minus 0 squared. What's the cool thing about subtracting 0 from a number?
It's the number.
It doesn't do anything, it just makes it that number.
Why did you?
She just rewrote it.
Because I no longer have two x's, so I don't have to discern between x1 and x2. Because I just have one x left. So then I'm going to go ahead and rewrite this as the square root of x squared plus y squared, because I just, the minus 0 took off because it doesn't do anything. So now I have an issue. I have my optimization equation, but it currently has two variables in it.
Okay, but tell me why you can't just plug 0 back in there.
I did plug 0 in.
Nope, in the x, the new one.
Yeah, I'm comparing 0 to another point. I already plugged in the 0, so now I need the other point.
Also, 0 is just gonna be that number.
Yeah.
That's why she rewrote
We already plugged the 0, 0 in, so I can't do it again.
it. Jeez.
I'm getting.
So wouldn't you just enter the
No.
No, this is my
Hold on.
example, 'cause
the ln x?
Yes, hang on to that for a second. Okay, I have my optimization equation in terms of two variables. Was I given any other equation or information that I could use to substitute and get down to one variable?
Line of x. Y equals line of x.
Natural log of x, but yes.
Oh, why did I just say line?
So my second equation I was given was y equals natural log of x minus x. So that means that y equals natural log of x minus x. So I can substitute this in for the y in my optimization equation.
Debbie's been saying that.
I know, so has Corbin, but I had to wait until I had everybody's attention. So now what I have is d equals the square root of x squared plus natural log of x minus x all squared. I know, that's
I really
super
think
fun.
we can get rid of all the squares, right? Like, drop all those cross out.
Well, I can't plug it into my calculator because I don't have an x value, but once I do, then I can. So this is where a square root kind of comes in handy for us, because as I'm looking at this, I have the square root of x squared plus natural log of x minus x all squared, right? I'm looking to minimize what's under the square root. So if I take the square root of a small number, it's just going to make it smaller. So I actually only have to optimize what's inside of it. I can actually leave the square root off from here on out. So now I just have that d equals x squared plus natural log of x minus x squared,
I don't understand why you can just
Yeah, why
Yeah,
can't
get
we
rid of
do
that.
that?
because the square root of a small number just makes it smaller. So it's not changing anything except for to make it smaller. So in order to get the smallest possible value, I already have to have the smallest possible value inside of it. So because it's making it smaller still, I only have to make what's inside the smallest it can be. Well, we had to get it down to one variable first.
Wait, so can you just do that every single time?
This is only unique to square roots and if I'm minimizing. This is only unique when I'm minimizing a square root, yes.
Wait, so what?
What?
Is the square root of like 0.5 still smaller than 0.5?
Because it's what times what equals 0.5.
But if we're trying
Well, I
to
don't
find the
know.
smallest we're trying to find the smallest number, yeah? So why would you not take the square root?
I will be in the end, but in order to find the smallest number with a square root, I have to have the smallest number inside the square root already. So that's why I don't really care about the square root part of it, because in order to minimize what's inside has to be the smallest it can be. That's something we can come back to. Just know that this applies when I'm minimizing and when I have a square root. Okay, we can just knock it off and pay attention to only what's on the inside. So now I have a much nicer equation to work with. So what I need to do now is I need to, what do you guys think? What's the next step?
I have no idea how you find
FOIL
that.
out the LNX.
Nope.
No.
What is the next step? So
Yeah,
I
but
got
that's
my
something in the end.
equation down to one literally
Equal to 0.
steps. No, before that.
Oh, this one.
Find the derivative.
Take the derivative. So now I have to take the derivative of this equation.
Okay.
Once I have it down to one variable, I take the derivative. So the derivative of x squared is what? 2x. Then what?
Plus 2, it's chain rule.
Yes, it is. And then what is the derivative of natural log of x minus x?
1 over x.
1 over x minus 1.
Oh, glad you guys remember.
This is simplified.
So what I'm going to do now is I'm going to try and simplify this a little bit so it looks a little bit nicer. So when I'm simplifying this one, I'm going to have, oh, that was fun. Okay, so I'm going to go ahead and FOIL this whole thing out because that's what's going to make it the nicest. So natural log of x over x minus natural log of x minus x over x plus x. This allows me to simplify this a little bit more, and that x over x becomes 1.
What the?
I just FOILed it out.
Wait, did the,
You know, each problem's gonna take up a whole piece of paper.
Some of them are shorter, some of them
Where
aren't.
did you just do the thing you just did?
I got negative x over x canceled and became 1.
Oh, okay, I didn't see you do that.
Yeah. I just simplified it a little bit. So the really awesome thing about this is I have natural logs in here, which means no matter how much I simplify it, it's still going to be a pain for me to actually solve and set that equal to 0 and find my 0. So we can actually graph it and find where it intersects my x-axis, and then that's going to be my 0.
So this is
Jesus, it's kind of long.
so
but
just
right.
say graph?
So then from here you would graph it, and I'm going to tell you what the 0 is just so we can move on to the next problem.
Oh, I kind of want to graph it.
Well, you can on your own time, but we need to move through. So when we do this, we get that our x value is 0.6328. But what was the problem asking for?
The distance.
No, it asked what point
The
was the
coordinates.
closest, right? So I have 1/2 of my coordinates. How would I find the other half?
Plug it back in.
Plug that back into the original equation it gave me, which was a natural log of x minus x. And when we do, we would get that the y value is equal to negative 1.0904.
That's the answer.
That's it,
How do we
because
know
those
that-
are the coordinates I was looking for.
How do we know that that critical point is the closest?
You would look at the graph around it. So if it's a minimum value or a maximum value, then that works.
Wait, so how do we find that point on the graphic section? For the x?
I'll show you later.
I'm
Or
just
I'll show
really
you in a minute.
confused.
What are you confused
Like-
about?
Because this is the natural log of x, kind of like the square root of x graph. Like a different
shape, but still the same.
Kind of.
I'm confused how you can have a critical point on that.
Well, a critical point is just where it equals 0. So then I would look around it if it was going from a negative to a positive, because that's a derivative graph. So if it went from below the x-axis to above the x-axis, going from decreasing to increasing, which means that's a minimum, which is what I would want. And then if it was going from above the x-axis to below the x-axis, that would be a maximum because it was increasing and then decreasing. So you're still going to have a graph around it that's going to help you determine whether it's a minimum or a maximum. But that is something, graphing calculator stuff we can work on. I want the process. That's more of what I'm interested in today is the process. Okay, and this is not one that you're going to see very often. I just figured we would kind of start with the hardest one. And then the next one will be easier. Okay. Well, I think we all need a
the
refresher.
despair of children?
I do not actually. I get very heartbroken. But I'd rather start with something hard and then back off to something easier because usually that helps kids understand a little bit more. So that one was difficult. I'm not going to lie, especially with the natural log in there, but I wanted to start hard and then back off a little bit. So this next one is actually significantly easier and takes up much less space than the previous problem.
It doesn't seem too bad. It just seems strenuous.
Okay, so example, I'm going to read it out loud because it is kind of a story problem and I don't want to write the whole thing.
Is this the second?
Let's read it and then we'll pull it out together. It's also in the notes that I haven't posted yet, so actually, never mind. The sum of two non-negative numbers is 30. Okay, so I'm having a sum in there. So let's assume that my two numbers are x and y.
This is way.
Oh, okay.
So the sum of two non-negative numbers is 30. So x and y are both positive. That is important to note because it could come in handy when I find my critical points or my critical values. It says find the largest possible product that results when the square of one of the numbers is multiplied by the second number. So I am optimizing my product, and it wants the product of the square of one of the numbers multiplied by the second number. So I usually just go in the order that I wrote them. So x I consider my first number, y I consider my second. So the square of my first number times my second is the product that I'm interested in optimizing.
Does it have to equal a specific value?
I don't know. That's what I'm going to have to figure out.
You're like, read that.
Am I looking for okay, let me reread it first and then we'll address that. So the whole thing so far says the sum of two non-negative numbers is 30. Find the largest possible product that results when the square of one of the numbers is multiplied by the second number. Okay, that's the entire problem. I know that I'm optimizing my product because it said that that's what I'm optimizing. Am I looking for a maximum or a minimum?
Max.
Max. What word gave that away?
Largest.
Largest. So make sure you're paying attention. It won't always say maximum or minimum, but it will give you some indication. Since product is what I am maximizing, this is my optimization equation that I would like to get in terms of one variable. So the good news is my story problem gave me a second equation to work with to make this happen. Which one of these variables do you think it will be easier to replace? The y, because it's not squared. So I need to go back to the other equation it gave me, and I need to solve for y. What am I going to do to make that happen? Subtract the x over. So my x plus y equals 30 becomes y equals 30 minus x. And I'm going to substitute that 30 minus x in for the y in my optimization equation. So now I have product equals x squared times 30 minus x.
Equals 0 or?
Not yet. I like to simplify it first, then we'll have to take the derivative. So of course from here, looking at it, it wouldn't be super easy to take the derivative. Actually, I'd have to do product rule, and that's stupid because I can just distribute and simplify first. So we're going to multiply the x squared into both of those terms. When I do, I get 30x squared minus x cubed. And then I take the derivative of that optimization equation. So p prime becomes what?
60x minus 3x squared.
60x minus 3x squared. What do I do with that optimization equation? And solve for what? X. Okay, so I'll give you guys a second to catch up, and then we'll go ahead and do that. As I'm looking at it now, it is a quadratic, so I could use the quadratic formula, but is that the only way to solve for x on this one?
No.
No, what else could I do?
Take this 6.
Take the negative 3x.
I was gonna subtract.
Um,
You know, don't listen.
actually, you could do that if that's what you wanted to do.
No.
It just won't be as nice. So let's take out a common factor first. So what can I take out of both 60x and negative 3x squared?
3.
I'm going to take out actually a negative 3x because then my x squared will become positive. So I'm going to take out a negative 3x, and when I do, I get negative 20 plus x. And all of that equals 0. I know when I'm multiplying two numbers together and their product is set equal to 0, what do I do with each of those factors? Set them equal to 0 and solve. So I get negative 3x equals 0, and I get negative 20 plus x equals 0. X equals 0 and x equals 20. So I came out with two possible answers.
For x, right?
For x. Yeah, this was just for x. How-
Which one's a max?
I would want to find which one's a max. So how would I do that?
Use the
You
big
can adjust it to the bigger number.
I just heard like 4 different things. What would I do with each of these x values?
Probably plug it into the stupid,
Plug them back into which equation?
the original.
derivative.
The product one.
What?
What?
I'm looking for the one that's going to give me the largest answer because I'm trying to optimize my product.
So the x squared times.
So I'm going to plug it back into this one or this one depending on which one you want.
Oh.
Because I'm trying to optimize this product P.
Let's go with
Do it with one on top.
Well, I can't because I don't have a Y yet.
Oh, I thought we were just solving for one.
No, not yet. Not till I pick which one is going to work. No brainer. Is the 0 going to give me a huge product?
No.
No, because 0 and 0 is just 0. So I can automatically knock that one out.
Oh, yeah.
And it
Let me
said
see it.
positive
Yeah.
numbers, didn't it?
It did say positive numbers, so that's another domain thing that I need to be thinking about. Of course, I should make sure that this doesn't give me a negative number. Does it?
Gives you 30. Or 10. For the y.
What does it give me if I
Oh,
plug 20 in?
Oh, 4,000.
4,000.
What the heck? 4,000?
Yeah.
Alright.
I thought-
Okay, so it worked. I just had to make sure it wouldn't give me a negative answer. I anticipated that it wouldn't because this one didn't even work in the first place, but it never hurts to check. So what was my question actually asking for in the end? It was asking us to find the largest possible product that results from this. So I don't even have to find the y because I already found what my product is, right? We just took the x and plugged it in. I got my product was what? We talked about it, it's 4,000. Yeah.
That's the answer.
So don't do the extra work if you don't have to. I wasn't asking for the x and the y. I was just asking for that maximum product. So that would be my final answer.
Ooh.
Alright, no more examples.
Mm-hmm.
Time for Uno.
No. No,
I don't
no.
have homework tonight, right? You said-
You do not have homework tonight.
I take 1 second.
Okay, I'll give you a hot second. That's fine.
How many more examples?
We will for sure get through one more. I might stop after that because I don't want to kill your brains.
It's already dead.
Okay, I don't want to kill them anymore.
It was dead the day Mag was here.
Whoa.
I still have managed for English.
First
Oh, I forgot that she's gone.
Two.
Doesn't matter.
Miss
What?
Winbigler, what the?
So it's Miss Hall.
Where's Morrison?
She's not here again.
Is it something you can tell us or no?
As far as I know, she does not have COVID. I do know that she wasn't feeling well,
She's scared of
but I
it.
don't know anything else.
Oh, Miss Simi.
Okay, are we ready for another problem? I will tell you that this next problem is one of my favorites to give on a test.
Well, this last one I did was my favorite.
Yeah.
It's a fun one, right?
It was so easy.
This one is definitely one of my favorites and one of the most popular
So you're
that
putting
I
this on-
assign.
This one will be on the final.
I can't promise that,
You should.
but it probably could be.
Wait, what is it? Is it the easiest one?
No, this is my favorite one.
So it's the hardest one?
It's not hard, no.
It's
Okay.
so popular based on the development.
A 30 by 40 rectangular sheet of cardboard
It's making me like.
I love this problem so much.
What is that symbol?
Huh?
It's not double.
No, that's inches.
Oh, I'm stupid.
No, you're not. That's okay. So this 30 by 40 rectangular sheet of cardboard is made into a box. Without a top, so that's important.
I can't spell it.
By cutting squares of equal size from each of the corners.
Oh my god.
It's not as bad as it sounds.
Is there a bottom?
To the box?
Yes.
Well, of course. It's
Well, there's
cut.
only 4 corners in the rectangle. Where do you want me to get the 5th side?
What does my problem say?
You're cutting squares.
No.
I don't think you're making the box.
Is
out.
made into a box without a top.
But that's
Oh,
So
okay.
it's gonna work, I promise. Okay, so by cutting squares of equal size from each of the corners.
Sorry.
And folding up the sides.
I think I have to go some next man. Actually, we developed a new plugin here.
I should do feel safe for cheese anxiety.
It's okay, I wouldn't have to go
I'm just
home.
starving.
Oh my gosh.
I'm starving. I got a little bubble of anxiety.
Also,
Find its maximum volume and the corresponding dimensions of the box. Oh, there we go. I love this problem so much.
I hate writing notes because I always write them all.
I should really
Look at this
not make it so hard to read for the kids online, should I?
They don't need that.
And I have a pause button.
Yeah, then.
That's true.
Wait, do they actually?
Not when it's live, but I think when I go back to the video.
Don't even cap. Ethan's probably eating a sandwich right now.
They asked him, Ethan. Ethan.
I'm like giving a second nap.
I was not. I had to check. I'm not
She was
muted.
so scared.
I
Not
didn't want to
paying attention.
remake this.
He's probably
Ethan.
He's probably taking a dump.
Sandwich right now.
Not listening. He just has his computer set up. I did that during the Jag on 9. I just like walked, turned off my camera, and walked
Half
away.
people left.
I left for like 5 minutes and I came back.
Okay, let's do the
I checked my
problem.
psychology.
Ethan's either making a sandwich or on the toilet.
I guess
Yeah.
there is actually if Ethan texts Deanna or not.
They're like, oh, he will after this.
Okay. So when I'm reading a problem like this, sometimes it's really difficult to understand. So my first step is always to draw a picture. Okay, that should always be your first step.
I'm not gonna jump.
Do we have to drop a cue?
So I'm starting with a rectangular sheet of cardboard. This rectangular sheet of cardboard has specific dimensions. It is 30 inches by 40 inches.
Oh yeah.
What am I doing with this sheet of cardboard?
Cutting squares or corners.
Cutting squares from each of my corners. We don't know the size of those squares, so I'm just gonna say that their side lengths are x. So from each of these corners, I'm cutting out an x by x square.
You have to draw it on each
I'm gonna
corner.
go ahead and not have that for
It is not to scale, and that's fine.
It could be.
I have a bunch of X's and making me mad.
Basically.
Yeah, I'm gonna not do that all the time.
So does the box have to be a cube or is
Look at my box.
because I don't think that's possible. Is it just?
It can't be a
rectangular
cube
box?
because if I'm cutting out the same from each
Okay.
side, then my sides are not gonna be the same.
Why is, okay, if it's just a sheet of cardboard, why does it say fold into a box?
Because I'm taking a sheet of cardboard and turning it into a three-dimensional box.
You want to make a box out of cardboard? I did that during one of my classes.
Okay,
I was online.
so it is asking me to optimize what?
The amount of space, volume.
Volume. It says right here that I would like to find the maximum volume, which means I need to start with the equation for volume of a rectangular box with no lid. So what is the volume of a box? Height, yes. Length times width times height. Right? We're kind of okay with that.
Yeah,
But we don't know the height.
But we don't know the height.
We'll be over here.
But I know everything else, and I can use a variable to represent the height. Correct?
oh yeah.
If I fold this up into a box, what is my length?
Oh, we don't
Your
know.
length is your
40 minus
width.
2x.
40 minus 2x, because I took this 40 side and I cut out 2 lengths of x from each of my corners, or 1 from each, and it came out to 2. So 40 minus 2x is the new length of this side right here. So that's going to be the length in my volume equation.
Oh my god. And we're just gonna find h.
If that is my length, what is my width? 30 minus 2x. And then what is going to be the height of my box? X, because that is the height or the length of the flap that I'm folding up.
Also, I don't get where you got 2 eggs, but
Here's 1 length of x. Here's 1 length of x.
Okay.
So I took my 40 and I took out 2 lengths of x to make my new length.
yeah.
Does that make sense? Okay. So now, what am I going to do?
Foil, I guess.
I'm going to multiply that bad boy out. Okay. So we do that. Do I want to do it all at one time, or do I want to work in groups of 2? Groups of 2. So we're going to FOIL this, and then we'll multiply everything by x at the end if we want to. So when I FOIL this out, I get 40 times 30 is 1200. 40 times a negative 2x is negative 80x. Negative 2x times 30 is negative 60x. Negative 2x and negative 2x is a positive 4x squared. I go ahead and I simplify inside of that. And I get 1200 minus 140x plus 4x squared. What'd you say? Nice.
So you want one, wait, what? What are you doing?
Combining.
Oh,
He's either Liam jumping the gun a little bit.
Okay,
He's
And
Marvel.
then do we
so
multiply-
simplified, I had the 1200 minus 140x plus 4x squared, but I still have an x outside, so I'm going to multiply that in. I'm also going to reorder this so it's a little bit easier to read. So highest degree to the left down to the constant on the right. So then this is going to become 4x cubed minus 140x squared plus 1200x.
Quadratic formula.
Not yet.
Equal to 0.
Nope.
You can take out a 4.
Derivative.
Derivative. I haven't done my derivative yet.
You're right.
So I like to simplify this, then take the derivative, then solve when it's compared to 0. So what's going to be the derivative of this problem?
12 x squared minus
3x plus 1200.
And now I'm going to compare this to 0.
Ow.
I'd take out a 12.
Okay, you can take out a 12 if you want to. If it's really probably not gonna help you that much, like it might.
Next thing, little.
Did you just say littler?
Then
What else could I use to solve this? Quadratic formula. I'm gonna save you the hassle of having to do it because these are huge numbers. You can do it on your own time. And I'm going to tell you that when we do, we get two options. We get x equals 5.6574, or we get x equals 17.6759.
It's the smaller one. You're playing mind games, and it's gonna be the smaller one.
I don't know.
13.6.
Well, all I know is I gotta plug it into the stupid other equation
I think that's-
Okay.
she's right.
We would plug this back in
to the second.
to our volume equation, all in terms of x, because I only have an x.
Think like any of the fluids.
And I want the one that's gonna give me the biggest volume.
Wait, so I can plug that into any.
Technically, yes.
Alright, that makes things easier, because then I know I can.
Plug it in and find out. Some of you take the 5.6574, some of you take the 17.6759.
And we do it in the 4x.
Doesn't matter.
This would be the easiest one to plug it into, but you could do it technically in any of these.
That's the best part, because I can't. I can't.
I can. That calculator plug that's really hard.
You know what? That way you can plug it into two equations and make sure you get the same answer twice.
That's true, you can do that.
Just blew my own mind.
Lauren, which one did you plug in and what'd you get? Yep. So is this going to be my optimum x value? No, I got a negative volume. So that clearly cannot work because I can't have a negative amount of space. So we obviously assume that the 5.6574 is going to work. We should plug it in to make sure I do get a positive. And you do get 3,032 approximately.
why can't we have a negative volume? It's just like the box is upside down, so flip it over.
No, flipped over, it still has the same capacity to hold.
I think
Gravitational force would make it impossible, but that doesn't mean it couldn't theoretically hold that amount.
when I get home, I'm watching Christmas movies tonight.
So we can't have a negative volume.
I've been watching.
I'm sure somewhere in physics you can, but here we cannot.
I watched that.
Okay, so what was this asking me to find?
Big number.
What was the
Volume
problem
and the
asking?
dimension.
Okay, so I found the volume, but I have to identify my dimensions. Right? So I need to identify my length, I need to identify my width, and I need to identify my height. The good news is I already know what my height is because my height was just x. So I still have to find the length and I still have to find the width.
So we just found the height.
Yeah, because that was what my x was, right?
That means that
So wait,
we have more steps.
We're almost done.
So you just like, if you take those 40 and the 30 and subtract them, what is it?
What like I was definitely about to use the 40 minus 2x for length. What if I do that? Are they gonna
Oh,
find that
no, it
wrong?
would be 40. It really doesn't matter because
Okay.
length and width are interchangeable. Okay, so our x value was our height, so we already found that one. To find our length, I do 40 minus 2 times the height. To find the width, I do 30 minus 2 times the height. When I do, I get, oh goodness, 28.6852 for my length. And I get 18.6852 for my width. And then, of course, my height is the 5.6574. So I found the max volume. And I found the dimensions of my box.
Here's a question.
Yes.
Most likely our last four, like rounded to the last four, there's gonna be the same.
If I'm taking whole numbers and subtracting out the same decimal, yes. Okay, any questions on that one?
Nope, I'm ready.
Anybody super duper confused about the last two that we've done? Because those are the most common types you're gonna see,
The last one had numbers that kind of made sense.
right?
Yeah.
Okay, I do think I'm going to stop here because I do not want to burst your brains. I'm more than happy to do another one though if you guys want,
No.
but I think we're okay stopping.
I actually kind of know what's going on.
That's good.
Where did this two, like, why did